Number 11, below is a dartboard. The diagram of the red circle is 20 centimeters. So let's start keeping track of this information and see if it's useful. So going across from one end to the other, this tells us that our diameter for the red circle, or the largest circle of all, is equal to 20. That tells us the radius of this larger circle, so we go r sub l, is equal to 10. Then let's keep reading. While the radius of the blue circle is 8. So we can mark it here. That's our radius for the blue circle. So the radius of the smaller circle, or blue circle, let's go r sub s, is equal to 8. Then we keep on reading. The figure is not drawn to scale. Yep. What is the probability if a dart is thrown, it will land in the red area? Okay, so this is asking for geometric probability. So we want the probability of landing only in the red area. So what are they talking about here is only the red area is this little donut section that kind of goes around this circular picture. So we need to find only the section here, and we need to cut out the smaller blue circle. So this tells us that we have our event, okay, which is going to be the donut section area going around the circle. And our overall sample space, or the total, will be actually the entire circles, or all the area, all the total area. So let's find our event. In order to find our event, we're going to need the area of the larger red circle. So this is going to be pi times radius squared. In this case, our radius is 10, and this gives us 100 pi. Then we're going to need to subtract this by the smaller blue area. So the smaller blue area is going to be pi times our radius squared. In this case, it's 8. So we get 64 pi. Now we subtract these quantities from each other, and 100 minus 64 will give us 36, and our pi's will be left over. So this tells us that, hey, our probability for the event, however, is going to be, so let's copy our setup here. And there we go. This will equal to 36 pi over our total. And we already actually found our total. Our total is going to be 100 pi. And this simplifies. The pi's cancel out, so we just have 36 over 100. And we're going to continue simplifying this fraction. So if you have hard time simplifying fractions, it's fine. However, we simply don't need it because it's probability. This is 36 over 100, or 36%. And there we go. This gives us 36%. And that's it for number 11. It'll be C. On to number 12. The stem and leaf plot below represent the scores of high school student basketball teams for one season. So we have our stems here and our leaves here. So if we look at the answers here, it looks like the key for each of these stem and leaves values would be the stems represents tens and the leaves represents the ones place. So for this first row here, it's really trying to say, oh, we have 39. And in the second row here, it's saying, okay, we have 40. Then we have 41. Then we have 45, 47, 47 again, 47, 49. And something very similar in our last row here. We have 52, 56, 56 again, then followed by 58. Now let's keep reading. What is the mode of the data? And we really just want to remind ourselves, well, mode is the most often. So out of all this information, what shows up the most? And it looks like it's right here. We have 3 47s, and nothing else shows more than 3 copies of itself. So our answer here is going to be D. Our mode would be 47. And that's it for 12. On to number 13. So we take a look at the picture before we need to look at anything else. Okay, so take a quick look here. Oh, we have some kind of linear equation. Now let's see what's happening in number 13. So number 13, a line is graphed on the grid. Okay, so it looks like we want to figure out which one of these equations matches this linear equation. So what we want to remind ourselves when we look at a linear equation, we want something in some kind of easy to recognize form, like the slope-intercept form, or y equals mx plus b. In this case here, we see that our y-intercept is 0, 4, so our b value here is 4. And we can use this to help us find our slope. So slope is the rise, so how much we go up by, and our run, or how much we go left and right by. So in this case, we're rising by 1, because we went from 4 to 5, and we ran by 3. So this tells us our slope here, our m value is going to be 1 over 3. So now we can generate or write our linear equation. We have y is equal to 1/3 x plus 4. So then now we check each of these situations and see which one best match. So it looks like, oh, it's right here, part B is exactly the same thing. So that works out. And that's it for 13. Number 14, it says, what is the value of the numerical expression? We have 2 square root of 27 plus 5 square root of 12. So we want to just quickly recall how square roots kind of work. Well, square roots is essentially just saying, hey, they are some variables that we're just adding together. We treat them just like variables. So if we have a statement like 2x plus 5x, well, this would give us 7x. So what does this mean for our problem here? When we have this problem here, what we want to do is simplify our radicals in such a way where they're the same. So let's remind ourselves off to the side here now. Well, the square root of 27 is the same thing as 3 times 3 times 3. So this gives us the square root of 3 times 3 times the square root of 3. And this simplifies to 3 square root of 3. So great. Our first term can be rewritten as 2 times 3 times the square root of 3, which simplifies to 6 square root of 3. We continue by copying down the addition sign and see what about the square root of 12. So the square root of 12 is equal to 2 times 2 times 3, which gives us the square root of 2 times 2 times the square root of 3. And that simplifies to 2 square root of 3. So we come back to this problem now. We have 5 times 2 times the square root of 3. And so this gives us 10 square root of 3. And now that both our square root statements are exactly the same, they're treated like variables. So we can just add the coefficient values in front. So we have 6 plus 10. This would give us 16. And we just add the square root of 3 afterwards. So our final answer would be 16 square root of 3. And it looks like it's C. And there you go. That's 14. On to number 15. Number 15, if the endpoints of the diameter of a circle are at -4, 9 and -8, 15, what are the coordinates of the center of the circle? So for any one of these problems, when order pairs are involved, it's probably a good idea to sketch a graph and see what's happening. So let's see what's going on. So I have 1, 2, 3, 4. So I have -4. Then we count up 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have some order pair right here. That's our first order pair. Then we have -8. So just going to count 4 more. 1, 2, 3, 4. So there's -8. And 15. So count 10, 11, 12, 13, 14, 15. Right there. So our next order pair is right there. So if we connect these 2 points, that'll be the diameter for our circle. And we're asked to find the center of the circle. Oh, so that looks like what we're looking for is some midpoint right here. So what we can do is look for the distance between each of these values. So if we start at -4 and go to -8, we're really just looking for the midpoint. So it looks like our x value here for the midpoint, so the midpoint of our x values is going to be -6. Then we want to count for the distance halfway between 15 and 9. So we count up here. We count up by 1. There's 2, 3, 4, 5, 6. So between 15 and 9, we really want about 3 units up. So that means that we can be 10, 11, 12. So the midpoint for our y value would be 12. So we have -6, 12. And it looks like it should be part D. However, let's make sure we're for sure that these are the values. Since our graphs are very rough sketch, we may be actually missing it. So let's remind ourselves what the midpoint formula is. It's the sum of the x values divided by 2, and the sum of the y values also divided by 2. So in this case, we're going to try to find our midpoint values again. So we have -8 minus or plus -4, if you want to think about that, divided by 2. And for our y values, we have 9 plus, stay consistent, we have 15 plus 9 divided by 2. And we continue simplifying our midpoint values. So for our x values, we're going to have -12 divided by 2. And that seems to work out. We'll end up simplifying to be -6. So our x values work out. Now we'll check our y values. So 15 plus 9 is going to be 24 divided by 2, and this gives us 12. And it looks like this also works out. So we can use our graph to also find our midpoint value, or we can do it numerically, reminding ourselves what the formula is. And that's it for number 15.